For today's lesson, our objectives are to find the lengths of horizontal and vertical line segments on the coordinate plane. And then in our next lesson, we will solve real-world problems involving coordinates and a coordinate plane. And these are the standards that will be addressed in this lesson and the next one. We have standard 6 NS8, which you can read here. And then we also have 6 EE2C, which you can read here. And finally 6G3. And so those are the standards that will be addressed in this lesson. So here we have some line segments that have been drawn on a coordinate plane, and our goal for today is to calculate the length of these line segments. So the first thing we need to do is we need to get the ordered pairs for the points that make up the line segment. So we're going to look at line segment AB. So we need the ordered pair for A, and the ordered pair for A would be -4, 0. And then we need the ordered pair for B, which is 2, 0. In the line segments that we use, they will all be horizontal or vertical. We won't have any on a diagonal today. So when we have a horizontal or vertical line segment, there will be one coordinate that is the same. And for A and B, the coordinate that is the same is the y coordinate. So we're going to cross those out because those will not help us calculate the length of our line segment. We will use our x coordinates for this. For our coordinates, we want to take the absolute value. And I suggest always listing the number that will have the largest absolute value first, and then the number with the smaller absolute value second. Since our original x coordinates have different signs, one's negative and one's positive, you will add the absolute values to determine length. So the absolute value of -4 is 4. The absolute value of 2 is 2. So the length of AB is 6 units. Now you could also find your length if you have a line segment by doing some counting. So you would start at A and you would go 1, 2, 3, 4, 5, 6. But really that second method works best if you have the lines already. If not, you'd have to plot the points, make sure that they're in the correct locations, draw the line segment, and then do the counting. And sometimes just doing the addition or eventually subtraction of the absolute values of your coordinates will be quicker. So if we take a look at C and D, C is at 3, 0. D is at 7, 0. So once again, our y coordinates are the same. So we're going to ignore those, and we're going to look at the x coordinates. So we start by taking the absolute value, and again, I would start with the absolute value of the larger number, and then put the absolute value of the smaller number second. Now in our previous example, the x coordinates had different signs, so we added. In this example, our x coordinates have the same signs, so we're going to subtract. So the absolute value of 7 is 7, absolute value of 3 is 3, 7 minus 3 is 4. And if you were to count that distance, you would find that it is also 4. Excuse me. Now, if we do have a situation where both of our coordinates are positive, you can actually skip the absolute value part and just subtract them as they are. If our lines are vertical, there's not much difference except for which coordinate ends up being the same. So if we look at point E, Point E has an ordered pair of 0, -8. F has an ordered pair of 0, 1. So this time, instead of the y coordinates being the same, it's our x coordinates that are the same. So we're going to ignore those. Our y coordinates, we take the absolute value. So we take the absolute value of -8. We take the absolute value of 1. And just like our previous example, when the signs are different, so we have a negative and a positive, we're actually going to add our absolute values. So the absolute value of -8 is 8. Absolute value of 1 is 1. 8 plus 1 is 9. And then our final pair, we have G and H. G has an ordered pair of 0, 2. H has an ordered pair of 0, 5. Our x coordinates are the same, so we ignore those. Our y coordinates have the same sign, so we're going to subtract as we did before. And since they're both positive, you can skip the absolute value part and just do 5 minus 2, which is 3. So for these 6 problems here, we want to plot each pair of points on the coordinate plane. We want to connect the points to form a line segment and then find its length. So for C, we want to plot that point at 3, 0. So I'm going to start at the origin. I'm going to come to the right 3. So there's C. And then I go back to the origin. I go to the right 8. So there's D. So C is at 3, 0. D is at 8, 0. And I'm going to connect to make that line segment. And then my y coordinates are the same, so I'm not going to use those. My x coordinates have the same sign, and they're both positive, so I can just do the straight subtraction here. 8 minus 3 is 5. For number 2, E is at -6, 0, so I would go to the origin. I go to the left 6. There's E. I go back to the origin. I go to the left 2 for F, and I connect. The y coordinates are the same, so I ignore those. Now in this case, my x coordinates are have the same sign, but they're both negative. So I do need to follow, or I do need to do the absolute value first. Absolute value of -6 is 6. Absolute value of -2 is 2. So 6 minus 2 is 4. For number 3, I put G at -7. So there's G. H is at 1, 0. So there's H. Now when I draw this line segment, I do have to go over EF, which is fine. This is just a practice, so it's okay if you cover those up. I'm going to scoot this up just a little bit. My y coordinates are the same. So I look at the x coordinates. They have different signs. So I take the absolute value and I add them together. Absolute value of -7 is 7. Absolute value of 1 is 1. 7 plus 1 is 8. For number 4, I go up 5 from the origin for J. And then I go up 2 from the origin for K. I connect. The x coordinates are the same, so I ignore those. The y coordinates have the same sign and they're positive, so I can just go straight to subtraction. 5 minus 2 is 3. For number 5, for M, I go to the origin, I go down 6. So there's M. And then for N, I go to the origin, I go down 3. And I connect. X's are the same, so I ignore those. My y coordinates have the same sign, so I'm going to subtract, but since they're both negative, I need to subtract the absolute values. So the absolute value of -6 is 6, absolute value of 3 is 3, 6 minus 3 is 3. And then for number 6 here, we actually already have those 2 points Plotted 0, -3 is the same as n, so I'm just going to cover that and put a p next to it. And q is actually the same point as j, so I'm going to cover that and rename that q. I'm going to connect. X coordinates are the same. Y coordinates are different, so I add their absolute values. So 5 plus absolute value of -3, which would be 5 plus 3 equals 8. And if you notice, I just put myself in the habit of putting the number that would have the largest absolute value first. That way I'm always in that habit whether I need to add or subtract. So what happens if the line segments are not on the X or Y axis? Nothing. Nothing changes. The only thing that'll change is your absolute values won't have a 0 in them. So if we look at line segment MN, M has an ordered pair of -5, 5. N has an ordered pair of -5, 1. The X coordinate is the same, so we're going to ignore that, just like we did if they were both 0. We look at our Y coordinates. They're the same sign, so we subtract, and since they're both positive, we can go straight to subtraction. 5 minus 1 is 4. You scroll down here a little bit to find PQ. There it is down there at the bottom. P has an ordered pair of -3, -10. Q has an ordered pair of 6, -10. Y coordinates the same, so I ignore that. The X values, the X coordinates have different signs, so I take the absolute value and add. Absolute value of 6 is 6, absolute value of -3 is 3, 6 plus 3 is 9. And for these, since those lines exist, you can double check your work by counting the spaces. And our final example, we have R, which is at 2, 2. We have S, which is at 6, 2. Y coordinates are the same. X coordinates have the same sign. They're both positive. So we can take 6 minus 2 to get 4. So as you can see, these are no different than when our line segments were on the X or the Y axis. So for 7 through 12 here, we're going to do the same thing we did for questions 1 through 6. We'll plot the points, draw the line, and then calculate the length. So A is at 1, -2. So there's point A. B is at 6, -2. Connect. Y coordinates are the same. X have the same sign. They're both positive. 6 minus 1 is 5. C is at -1, 3. D is at 5, 3. Connect. Y's are the same. Different signs. Take the absolute value and add. Absolute value of 5 is 5. Absolute value of -1 is 1. 5 plus 1 is 6. E is at -3, 4. Here's E. F is at 1, 4. Connect. Y values are the same. X values are different signs. So we add the absolute value. Absolute value of -3 is 3. Absolute value of 1 is 1. 3 plus 1 is 4. G, scroll this up a little bit, is at -3, 2. So there's G. H is at -3, 6. Connect. X coordinates are the same. Y coordinates are the same sign and they're positive, so I can go straight to subtraction. 6 minus 2 is 4. J is at -1, -6. So there's J right there. K is at -1, 4. So it's right there on EF. And connect, and that's going to be a pretty lengthy line segment there. X coordinates are the same. Y coordinates have a different sign. Let's take the absolute value and add. Absolute value of -6 is 6. Absolute value of 4 is 4. 6 plus 4 is 10. And finally, L is at 5, 6. There's L. M is at 5, 1. There's M. Connect, and we go through point P there. X coordinates are the same. Y coordinates have the same sign and they're positive. So 6 minus 1 is 5. And that was today's lesson. Hopefully this helps.